We have been looking at the resultant of coplanar concurrent forces. In the previous lecture, we saw the parallelogram law of forces to find the resultant of the forces. In this particular lecture, we will be seeing the next two methods, which is triangle law and polygon law. These two are also graphical methods. Now, if you try to recollect what we learned in the previous lecture, we have here a parallelogram where this is F1 and this is F2, and we saw that the diagonal of this parallelogram, there are two diagonals, one here and the other here, but the parallelogram law says that the diagonal passing through the point of concurrency, this is the point of concurrency, and this is the angle between the two forces, and this is the inclination of the resultant R with respect to F1. So let's say this is A, this is B, and this is C. Now if you recollect what you would have studied in maths, that a parallelogram, if you take it, the opposite sides are always parallel. This is parallel to this and of equal magnitude. This side is parallel to this and they are of equal magnitude. Since this is F2, I can also write this as F2 because they are parallel and the magnitude is also same. If this is theta, then this is also theta. Now the triangle law says that, now try to cover up this particular part in the parallelogram. I am trying to cover up the top part of the parallelogram. Then what will happen? I am removing this, and what will be left out is a triangle. Okay, now this is what the triangle law says. When two forces acting upon a body, say F1 and F2 inclined at an angle theta, if they can be represented by the sides of a triangle taken in order. Now what do we mean by taken in order? Now first of all, you have to draw the first force. This is the tail of this arrow and this is the head. When I say in order, the next force has to start from the head of the first force and then it has to go like this. This F1 is parallel to this F2 is parallel to this, such that this angle is theta. Then the closing side of this triangle represents the resultant of these two forces. So this closing side, third side, represents the resultant in the opposite order. Now what do we mean by opposite order? The third side, again, if at all I have to draw from the head of F2 and then the arrow is pointing here, whereas the resultant will be in the opposite order. That's what the triangle law says. Let me write this triangle law. When two concurrent forces, say F1 and F2, inclined at an angle, acting on a body, can be represented by the two sides of a triangle taken in order, then the closing side, or in other words the third side, represents the resultant in magnitude and direction in the opposite order. So this is what we mean by opposite order. Actually it has to be in this direction, but it is in the opposite order. Now the triangle law, if you look up at, I have removed the top part and I am retaining it. So we can call that triangle law is a subset of parallelogram law. Now all you have to do is just like what we did in the case of parallelogram. You have to take a graph sheet, plot F1 using some scale on the graph sheet, and using a protractor you measure an angle theta here. On this line you mark F2 to some scale, then complete the triangle, and this length will give you the magnitude of the resultant, and this inclination will give you the inclination of R with respect to F1. The same thing can also be done in a mathematical manner. The mathematical formulation of triangle law is called Sine Law. Previously we saw the mathematical expression for parallelogram law is cosine law. The mathematical expression for triangle law is sine law. In order to do that, let's name this triangle as OAB. Since this is theta and the entire angle is 180 degree, this will be nothing but 180 degree minus theta. This anyway is alpha, and if you do this, this angle will come out to be theta minus alpha, because all these three angles put together it has to be equal to 180 degrees. Now the sine law says that just taking any general triangle, say I am drawing a triangle of sides A, B, C. The angle opposite to side A is alpha, the angle opposite to side B is beta, the angle opposite to side C, I am taking this as gamma. If you have a triangle with sides and the included angles as this, the sine law says that A by sine alpha is equal to B by sine beta is equal to C by sine gamma. So I can find out this angle. Okay, how to do that? In this case, if I apply it, it will be F2 by sine alpha is equal to R by, this angle is nothing but 180 degrees minus theta. So it is R by sine of 180 degree minus theta. Theta anyway is given in the problem because inclination of the two forces is given, and R we have to find out. So if you substitute everything, F1 and F2 are also known, from which you can calculate alpha. Now in order to find alpha, I should know R. According to this sine law, it says you can calculate the side of this triangle, any side, provided you know any other two sides and the included angle. Now what do we mean by that? It says if I want to know A, it is equal to b squared plus c squared minus 2bc cos alpha. And if I want to know b squared, provided a and c are known, then it is a squared plus c squared minus 2ac cos beta. If I want to know c value, c squared is equal to a squared plus b squared minus 2ab cos gamma. Here f1 is known, f2 is also known, the only unknown is r. How do we calculate it? Using this, if I apply this formula here, it will be, I want to calculate r, so r squared is equal to f1 squared plus f2 squared minus twice of f1 f2 and the included angle between f1 and f2, which is nothing but cos of 180 degrees minus theta. Now using this formula we can calculate the resultant, and once we find out the resultant we can substitute it here to find the alpha value. When there are two forces which are concurrent and acting upon a body, we can find the resultant using the parallelogram law. And we also saw that we can use triangle law to find the resultant, and triangle law is a subset of parallelogram law. Suppose there are more than two forces. This is a body. Several forces, let's say, are acting upon this body. F2, F3 and F4. When more number of forces, that is more than 3, are going to act upon the body, also they are all concurrent at a point, we can find the resultant by using what is called the Polygon Law. It says that when a number of concurrent forces acting on a body can be represented in magnitude and direction by the sides of a polygon taken in order, then the closing side represents the resultant in magnitude and direction in the opposite order. Now we can solve this using the graphical method. Take a graph sheet, then measure f1 on the graph. All you have to do is, using some scale factor, draw f1, and from the head of f1 you have to place f2. Here parallel to this I am drawing f2. Then from this head you have to draw f3. f3 goes like this, and f4 is directed like this. Now what is the closing side? The closing side is nothing but this one. So this one represents the resultant in magnitude and direction in the opposite order. Okay. Now what is meant by polygon? Polygon is nothing but a closed figure having more than 3 sides. So we have represented all these forces using a polygon. Then the closing side of this closed figure will represent the resultant in magnitude and direction in the opposite order. However, there is no mathematical formula to derive the resultant. All we have to do is consider two forces and then find the resultant of these two forces. First of all, say it is R1. You can use either triangle law or parallelogram law. And once you find the resultant, again combine this with F3, and that will give you another resultant which we call as R2. And combine this resultant with F4 to arrive at the final resultant. So it's little bit cumbersome if we have more number of forces. In such cases, we have to resort to a new method which is called the analytical method, which we will see in the next lecture.